Okay, so now we're going to look at functions in this next section. And so we're going to add functions, subtract functions, multiply functions, divide functions, and figure out the domains when we add, subtract, multiply, and divide. But before we figure out the domains for adding, subtracting, multiplying, and dividing, let's just look at the domain of this one. What's the domain of that function right there, just as it is written? All real numbers, negative infinity to infinity. You can put any number in there and it'll come out with a number. How about the domain of this one? All real numbers. You can put any number in there and you'll get a real number result. Okay? So if I'm taking f plus g of x, I'm just adding these two functions together. That's simply what I'm doing. What's 2x plus negative x? X plus 7. So f plus g of x in this situation is x plus 7. What's f minus g of x? Well, you take f of x minus g of x. What's 2x minus a negative x? 3x. And 2 minus 5 is negative 3. Okay? So the domain of this one, is a domain restricted at all for this? No. It's all real numbers. Negative infinity to infinity. What's the domain for this one? All real numbers. F times g of x. Okay, this one's a little more complicated. What do we do on this one? Well, they're both binomials, right? How do you multiply binomials? FOIL. We take the first times the first, which is 10x, outers, which is negative 2x squared, inners, which is plus 10, last times last, which is negative 2x. So this winds up to be negative 2x squared plus 8x plus 10. Now, is there anything that would limit this domain? No. So it'd be negative infinity to infinity. The last one of these, f over g of x, would be 2x plus 2 over 5 minus x. Can we simplify that at all? No, it is just the way it is. Now, is there anything that limits the domain of this one? Negative 5, no, positive 5. Positive 5. Because if you put a 5 in here, you get a denominator of 0. So the domain for this one is going to be negative infinity to 5 in union with 5 to infinity. That's how it's written. Okay? That is how it's written. Okay? Let's do the same thing for f of x and g of x here. Now, the square root of x here, is there anything that limits this domain? You can't have any negative numbers, right? So the domain starts at 0, so it includes 0. So you don't have a parenthesis 0, you actually have a bracket 0 because it includes 0 all the way up to infinity. Parenthesis. Anything that limits the domain of x here when it's the absolute value of x? Nope, you can put any number in. Okay. So, what's f plus g of x in this situation? It's simply just the square root of x plus the absolute value of x. And it's just that. If you want to look at the graph of it, we'll do it on Desmos really quick. Boom. Boom. Y equals the square root of x plus So over plus the absolute, absolute value. All right, how do I do absolute value symbols here?
It's on the backslash. Control shift backslash.
Shift backslash, there it is, absolute value of x. Okay, so that function looks like that. Okay, what's the domain of that function? 0 to infinity. Okay, so if you need to look at it, you can look at it, but the domain is the same as this domain, 0 to infinity. F minus g of x is the square root of x minus the absolute value of x. If we look at that graph, we just change this plus to minus, and it looks like that. Does the domain change? No. The range changes, but not the domain. So the domain is, oop, Mr. Bierschbach screwed up. There, 0 to infinity. What's f times g of x going to look like? Well, it's going to be the square root of x times the absolute value of x. Oop. Just going to look like that. So if we look at that crazy graph, we're going to take this out and put in a well, I think it knows it's multiplication, but I'll still throw in a multiplication symbol. And there we go. Looks like that. Okay? Does that change the domain at all? Domain is still 0 to infinity. Where it gets complicated is f over g of x. So we have the square root of x over the absolute value of x. Okay? If we look at this one on Desmos, because it'll help if we look at the graph. It'll look like that. Okay? Any change in the domain? Nope. No change in the domain. So in this one, it'll also be 0 to infinity. But can we include 0? No, because you can't divide by 0, so it's going to be parentheses 0 to infinity this time instead of including 0. Okay? So you'll have some problems like that, and then you'll have composite functions, but you won't have the nasty composite functions today. You'll just have the fill in the number composite functions. Okay? So what you do is you put the number into this function first, and then whatever that answer is, then you put that answer into this function. So f of g of 2, well, you find g of 2, and you get 4 minus 2, which is 2. So then you find f of 2, and it's 2 times 2, which is 4 plus 1, which is 5. So f of g of 2 is 5. G of f of 2, you put the 2 in to the f function first. So f of 2, we just said was 5. So then you find g of 5, which is 5 squared, or 25 minus 2, which is 23. Okay? So you put this answer into there. Okay? So again, not very many problems. It shouldn't take you too long to finish. So let me assign out 1.4a to you. On Friday, we'll do 1.4b, and then come next Monday, we're going to get ready for a quiz over everything we've learned so far.
Get ready or take it.
I think that day will be get ready for the quiz.
Okay.
I would like to take it that day, but I don't know. I think I'll review and maybe give you a sample quiz.
I'll like it, Sam.
Yeah. So we'll see what happens. But that's the plan. But